Good evening. This is Professor David J. De Los Reyes. Okay, my topic this evening will be a problem on the evaluation of a differential equation that could be solved by using integrating factors. Okay, let's proceed, guys. This is a new topic on my channel. I am now on lesson DE number 22 under the topic a complete course, differential equation, and it is a differential equation that can be solved or solvable using integrating factors. I will give you one example this evening. Okay, let's proceed. The given differential equation is dy dx plus 2 over x times y equal to 4 the natural logarithm of x over x cubed. Find for the general solution. Okay, let's proceed with the solution, guys. Solution. This is a similar simple. The given differential equation is similar to the form dy dx plus p of x times y equal to q of x. Actually, this is case number 1. Case number 1. And the general solution for case number 1, or the setup of the solution, is actually this one, under case number 1. Since this is dy dx, this is y, the general solution should be y times the integrating factor equal to the integral of the right hand side. The right hand side is actually q of x times the integrating factor times dx. So, meaning to say, to bring out the general solution, compute for the integrating factor, then try to evaluate the right hand side. Okay, let's proceed with the solution. P of x will be, by observation, it is actually 2 over x. This is actually P of x. P as a function of x. It's just a designation. Okay, and Q of x is actually the right hand side. A little bit complicated. It is 4 natural logarithm of x over x cubed. Okay, and the formula for taking the integrating factor for case number 1 is actually this one. That's the formula. The integrating factor for case number 1 will be e raised to the integral of p of x dx. You must have to evaluate the integral of p of x dx to get the integrating factor. Okay? So they should now be equal to e raised to the integral. What is p of x? P of x is actually 2 over x. So this is 2 over x times dx. Okay, proceeding with the integration on the exponent. Okay, so this is e. This is exponent, right? We bring out 2. So this is 2, the integral of dx over x. And luckily, the integral of dx over x, we could integrate that one. It is simply natural logarithm of x. So this should be equal to e raised to 2, the natural logarithm of x. Right? Or under the laws of exponent, we could, or logarithm rather, we could remove this 2 here and put 2 over here. Because if we try to simplify this one, it can be written as 2, the natural logarithm of x, or it can be written as the natural logarithm of x squared. But what is the significance of this? Actually, we are taking the antilog of the right hand side. E raised to the natural logarithm of any given function, okay, it will just be simply the given function. Because e raised to the natural logarithm of x squared, actually, this is antilog. It will cancel out. right? So what will remain on the right hand side? It's just like the antilog of a logarithm. It's just simply the given function. So a raised to the natural logarithm of x squared is just x squared. Or the integrating factor for this problem is x squared. Okay? You already have calculated or evaluated the value of the integrating factor, and what comes out is x squared. So to bring out the solution, we will follow this form here for case number 1, the general solution for case number 1. It is y times the integrating factor equal to the integral of q of x, the given right hand side, times the computed value of the integrating factor times dx. Substituting value, this should be y. Integrating factor is x squared equal to the integral q of x is actually this one. So I will write it for natural logarithm of x over x cubed times the integrating factor x squared times dx. X cubed can be written as the product of x times x squared. So actually this x squared cancels. So what will remain on the right hand side will be, we bring out the for now, the integral of natural logarithm of x over x times dx. So the meaning of this is that to bring out the solution, we must have to evaluate this integral. Okay? And I think it is under the form, we can use the integral of u dv, that is under integral calculus, is actually equal to ub minus the integral of b du, or the integral of b du. Okay? This integration here is similar to this. So we must have to bring out a u and b, and we will try to evaluate the integral of b du to compute for the integral of u dv. Okay? So as a trial, we will let u equal to the natural logarithm of x. It's just a trial. Maybe if what comes out will be not a solvable integration, we change the letting of the value of u. But for the meantime, we will let the value of u equal to the natural logarithm of x. Du will be dx over x. Okay, we are taking differential of both sides. So if u is natural logarithm of x, there should be a dv, right? So what will remain for the dv will be the ratio dx over x, right? Because we let this as u, so the ratio of dx over x will be dv, so that it falls under the integral of u dv, right? So if dv is actually equal to dx over x, solving for the value of b, we must have to take the integral again of both sides, another integration. The integral of the differential of b is just b, equal to the integral of dx over x. And the integral of dx over x, it's just natural logarithm. So b is actually natural logarithm of x. Okay? So we now have a value of u. Okay? And we now have a value of b. Okay? Okay? So we could evaluate this one, the integral of b du, since we are now given b times du. And du is actually, what is du? Du is dx over x. Okay, so we'll try to evaluate this one separately, okay? The integral of natural logarithm of x over times dx over x, it falls under ub minus the integral of b du. So substituting values now, u is natural logarithm of x, right? And what is b? It's still natural logarithm of x. Minus the integral of b, natural logarithm of x, times du. What is du? It is dx over x. Okay? These are similar terms. So actually, it can be written as simply natural logarithm square of x. Okay? This is minus. And if you try to notice it, this is minus. We bring it to the left-hand side, so this will become 2 times, right? 2 times the integral of natural logarithm of dx over x equal to the simplification of this is natural logarithm square of x. But we are only interested on the integral of the natural logarithm of x dx over x. So we will remove this 2 here. So we will multiply this by 1/2. So these 2 here cancel with this. What will remain on the left hand side will be the integral of natural logarithm of x dx over x equal to, there is now a 1/2 here because natural logarithm square of x times 1/2 is 1/2 natural logarithm square of x plus a constant of integration c. So if we try to go back here, the final general solution now, we will follow this. It should be y times x squared equal to, there is a factor 4 here, 4, times the integral of this. The integral of this, in which we did this as this, is actually 1/2 the natural logarithm square of x plus c. 4 times 1/2 is 2. So the final answer will be x squared. I will try to rearrange x first. So this should be x squared y equal to 2 natural logarithm square of x plus c. That's our answer. Or as simple as that one, guys. Okay? That is an example problem on how to solve a differential equation by using integrating factors. So meaning to say, first step is actually try to visualize the given equation. Does it fall under case number 1 or case number 2? Obviously, the given problem is under case number 1. So if it falls under case number 1, this is the